Hey YouTube, in our exploration of quadratic functions, we're going to be spending a lot of time doing what we call factoring. And so factoring is exactly what you remember it as being when you were saying, I don't know, like fourth grade or something like that, you were doing division, where you take like a number that is basically a product of a bunch of different primes and multiply it together. So we'd say, well, this would be the same thing as 3 times 4. And, perhaps we could say the 4 even breaks down even further. And I don't know, we drew these, we called them hockey sticks, For the most part, they don't always look like hockey sticks, which is the weird thing, but we called them that anyways. And we say, you know what, we could rewrite 12 as the product of 3 times 2 times 2, or even better, sometimes we write it this way. We say 3 to the first, 2 to the second. And so this would be completely factored because we broke it down into a product of primes. Well, same thing kind of happens with algebraic expressions, and most especially in this video, we're going to talk about trinomials. We talk about trinomials of this form x squared plus bx plus c. We're going to be factoring expressions such as this one here. But I want to point this out where the a value is 1. Okay, and so before we do this and kind of go through this little mnemonic over here, basically what we're going to do is we're going to explore what happens, when we do the opposite of factor, which is multiply stuff back together, okay? And so what I've done is I've got, 4 pairs of binomial linear factors here. So we say this is binomial times a binomial. We've seen this before. As a matter of fact, we use the FOIL method to multiply this. So we say FOIL, F stands for first, so you multiply your first 2 factors. So we get x times x is x squared. We say outside, so outer 2 factors, x times 5, so that's 5x. We say inner 2 factors, so that'd be the 3 and the x here, we'd say plus 3x. And then the last 2 factors, which are the 3 and the 5, so we say 15. So this simplifies down into x squared plus 8x plus 15, okay? And this would be our quadratic trinomial expression with an a value of 1. So this next expression, we're going to do this a little bit quicker here, but x times x, get x squared, x times 5 is 5x. In this case, we get negative 2 times a positive x is a negative 2x, and then a negative 2 times a positive 5 is a negative 10. So combining like terms here in the middle of this one, we say I've got x squared, a positive 5 and a negative 2 add up to be 3x, and then those 2 factors here, negative 2 and 5 multiplied out to be a negative 10. So this case, this is our standard form quadratic thing with an a value of 1. We say, all right, so now x times x is x squared. X times negative 4 is minus 4x. Negative 3 times a positive x is a negative 3x, and then a negative 3 times a negative 4 actually gives us a positive 12. So this simplifies down into x squared minus 7x when you combine like terms here, and we say a positive 12 in the back there. Still has an a value of 1. And then this last set here, this is kind of one of my favorites here. We say x plus 3x minus 3. We say x squared. I get minus 3x. Straight up gets plus 3x, and we say positive 3 times a negative 3 is a minus 9, negative 9, but these 2 factors cancel out in the middle. So we get x squared, I'm going to write it like this, which is a weird thing, plus 0x minus 9, and I'm also going to write it this way. We say x squared minus 9. These are both the same thing, but I'm going to put a box around this when we say, well, in each of these instances, what do we notice? I mean, is there any type of connection between these 2 numbers that we're putting in the back of these linear factors here, these binomial linear factors, that relate to the expression that they were in? So perhaps if I switch over colors here, but we can see a little bit better. But, I noticed that when I multiplied these out, every time I did this, these middle 2 factors like 5x and 3x, I got those because I was multiplying, say, the 3 times an x or the 5 times the x. And when I add those together, I get this middle term right here. And I think this is true for all these. So like 3 plus 5 is 8. If I look down this next expression here, we said x minus 2, x plus 5 in our factors, and a negative 2 and a positive 5 add up to be a 3. This is pretty cool. We say a negative 3 and a negative 4, those add up to be a negative 7 in your answer expression. And this negative 3 and positive 3, those added up to be a 0, quite technically, okay? So what we're seeing here is this. When you factor an expression of this form, we say, this is very true, we say x squared plus bx plus c. We say we'll always factor in x plus m, x plus n. Given that m and n, they do this. They add to be this middle term. So we say the sum right here, okay? And then we're going to say it's a product in the back term there. So we say when you multiply this m and this n, you get this back number here, and that's the next thing we're going to go show. Maybe we can switch over to like, an orange here, but check it out. We say, if I were to say this 3 and this 5 here, multiply them, I get this 15. So this back number here is basically the product of these 2 values right here. So we say negative 2 times positive 5 is negative 10. This positive 12 came about because we multiplied a negative 3 and a negative 4, and then this negative 9 was a positive 3 times a negative 3. Okay, so basically, we just need to memorize that when we factor an expression, basically do the opposite of FOIL. We're going to go backwards. We say we're looking for 2 numbers here, essentially. 2 numbers that add up to be this middle coefficient, this b, and that multiply out to be the c. So when we do these here, basically, I think a good practice, I've seen this happen before, is to write out the factors of, say, negative 28. So we say, what are the factors of 28? We say 1, 2. I don't think 3 goes into 28. 4 does. 4 times 7. So we say 4, 7. I suppose, 14 goes into it. 14 goes into it, and 28. And we could say that any of these could be positive, any of these could be negative, okay? I don't think I've missed any. But essentially, I want two numbers that add up to be a negative 12. So we say, what two numbers on this list could add up to be a negative 12? Do any exist? And keeping in mind that this last number multiplied out to be a negative, they can have opposite signs. So I notice here that I say if they have opposite signs, when I add them up, they kind of, subtract a little bit here, but we say I could have a negative 14 and a positive 2. So we say my two factors here, I'd have x's in the front, but I say is a negative 14 and a positive 2, and the reason why is because these two things multiply out to be this negative 28. We wrote those out over here. And when you add these up, you get the middle term. So this is kind of what we're doing with all of these. You'll notice in the next one here, I could write out the factors of 48, maybe we should, but I'm going to be using a y instead. I say, can I think of two numbers that multiply out to be a negative 48? So I say 1, 2, 3 indeed does go into that 16 times. 3, 4 does. 4 does. 5 does not. 6, I believe, does. Okay, so we say 6, 8, and then we also have, what else do we have here? Not 9, not 10, 11, 12 goes into it. 12 goes into it 4 times. We said 3 times 16, 2 times 24, and then 1 times 48. Okay, so all of these. They multiply it again here to be a negative. So one of these has to have a positive, the other one has to have a negative, and they add up to be a negative 2. So I want two factors that are, like 2 apart from one another if I can stand to find these things. So we say, I don't know, can I find two factors that are 2 apart here? I think that these two right here are. Okay, so we'd say, all right, it looks like I'd have to have, in this case, a negative 8 and a positive 6. Because these would add up to be my negative 2 in the middle. So I'm going to do one more with you here. Then I'm going to leave the other 3 for yourselves there. But we say, okay, looking at this one here, again, they multiply out to be a negative. We say, what are the factors of 8? We have 1, 2, 4, and 8 are the factors of 8. Let me fix this 4 and 8. And since they multiplied out to be a negative, I'm going to put an x and an x here. But one's positive, the other one's negative. So I say, which two of these factors add up to be a positive 7? If they both have opposite signs, they must be 7 apart from one another. So I say this 1 and this 8 are definitely that. And I say it'd be a positive 8 and a negative 1 because that would add up to be a positive 7 in the middle, and they would multiply out to be a negative on the outside here. So that's how you would factor trinomials of this form right here, x squared plus bx plus c, where the a value is 1.